Welcome back for your review for your exponential quiz on Tuesday. So now I'm looking at for some reason, both of those were written as number 10. I apologize. But we're on to looking at the graph to come up with exponential functions. So the graph represents the number y of customers to a new bookstore after X weeks. Make a table to help you analyze the pattern. So we're going to look here at all our points, and they gave us some nice points to work with. Weeks are our X values, customers are our Y values. So our first point is right here, 0, 20. At 0 weeks, we had 20 customers, or in other words, the beginning, our very start. After 1 week, we had 40 customers. Sorry, that should be a 1. After 2 weeks, we had 80 customers. 3 weeks, we had 160. And at 4 weeks, we had 320. So how many customers were there originally? The original is always the 0 when X is 0. So originally, we started with 20 customers. The common ratio. The common ratio, another term we use is multiplier. It is how did this multiply to become that? And that is the basis of all exponential functions. If there is not a constant multiplier, it's not exponential. But we can see here, 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. 160 times 2 is 320. So our common ratio or our common multiplier is 2. It is the number that we multiply by over and over and over again. Write an exponential function that represents this situation. So I'm going to use some extra paper here to help explain this part, and then we'll come back to it. Remember, every exponential function can be written in the form y equals a times b to the x. A is your initial value. B is your multiplier or your common ratio. X is the number of times that you multiplied. So looking in this problem, we've already found our A and B. We have everything we need to write this equation. And that's why we asked you it in this form to start off with. Other problems will be a little more difficult. How many customers are there originally? 20. That is my A value. So y equals 20 outside. The common ratio was 2. So 20 times 2 to the x. And remember, exponents mean you keep multiplying. So what this equation means is we started with 20 and we multiplied by 2 over and over and over again. And that's what we did. We started with 20, we multiplied by 2 one time and got to 40. We multiplied by 2 twice and got to 80. Multiplied by 2 3 times and got to 160. Approximate the number of customers after 7 weeks. Well, now if we're saying 7 weeks, the way we would say this mathematically is we want to evaluate for x equals 7. So we just take the equation we wrote here, y equals 20 times 2 to the x. But now we're going to replace x with 7. So now we have y equals 20 times 2 to the 7th. If you put this in your Desmos calculator, do not put y equals this part. The y drops, and you only put 2 to the 7th times 20 in your calculator. And I will do that on a handheld calculator. Your Desmos would look a little different. If you think you have trouble doing that on your Desmos, please ask me. So now it's at 20 times 2 to the 7th. And you would end up with 2,560 customers if the exponential function held. So we could write this a couple different ways. You could do it as a point, 7, 2560, 2,560. You could say we expect 2,560 customers. Or you could write f of 7 equals 2,560 if you want to do functional notation. Any of that would be acceptable, and you would get full marks on your quiz. Number 11, determine whether each function represents, determine whether each function represents exponential growth or decay, identify the percent rate of change. Now, there's two spaces here. First, you tell me if it's growth or decay, then you tell me what the rate is. This is one of the important things we have to remember. The number given here is the multiplier. So I have a multiplier of 1.09. If your multiplier is bigger than 1, it's growth. If it's smaller than 1, it's decay. I look here, my multiplier is bigger than 1, so I know I have growth. Now, the R value is how much you grow by. So if my multiplier is 1.09, I grew by 0.09 or 9%. What that means is 1 is what I started with eventually in the beginning. Since I'm multiplying by 1.09, it means I'm getting 9% bigger. And remember, that comes from your growth rate formula. If you had 1 plus R, this is how you get your growth factor. So if 1 plus R equaled 1.09, then R must have equaled 0.09. And the easiest way to think of it is, what is my distance from 100%? This is 9% bigger than 100%, so my R equals 9%. These ones people seem to have a little bit more trouble with. So if I'm looking for growth or decay, all I care about is the number in the parentheses, my multiplier. This is smaller than 1, so I know I'm looking at decay. Now, when I look at my decay rate, that is different than my decay factor. My factor is 0.93. So from 100%, I'm going to change that to 93%. What was my change from 100% to 93%? I decayed at a rate of 7%. It's very important you see the difference in this. Your factor is 0.93. Your rate is how much you change from 100% to become your factor. So this has a rate of 7%. That goes over number 10 and 11 on your review, and I will be continuing on the next clip. Thank you very much.